I think AI is going to change how we do things. I joined A-Star in 2022 to set up this new area of growth and focus. You can think of us as a bridge between the science and industry. Within weeks, we are able to work with our industry to scale up, not just for domestic use, but for global as well. We need to stay relevant by constantly reinventing ourselves. And I think that is critical, right?
Kelvin Zin is an engineer-turned-strategist driving Singapore's sustainability and deep tech innovation. After shaping national capabilities across space and advanced manufacturing, he now leads R&D that powers Singapore's green future.
If you now look at sustainability, we need both speed and scale. Because without scale, there's no impact. The glaciers are melting, so we need to do both at the same time.
I'm an entrepreneur and I wanted to get plugged into the Singaporean innovation ecosystem. What would I do? Who would I approach to get started?
I'll put it in two broad buckets. If you are outside Singapore,
Hey, hello everyone. Welcome again to FutureScale's Built to Scale series. Today we are very pleased to have join us Kelvin Zin, who's the Director of Science and Engineering as part of the A-Star Research Council. But before we get to his very interesting background and have him explain a little bit about his past and what his role is at A-Star, a few things that we want to talk about today. One is of A-Star is, in my opinion, a bit of a novel entity and actually quite productive and quite impactful to the Singaporean economy. And then in some of the conversations that Kelvin and I have had in the past, he mentioned something very interesting to me, which is the idea of intentional innovation versus serendipitous innovation. So we're really going to try to see if we can draw some of that out and how does that get implemented in terms of building thoughtful, synergistic ecosystems. So, Kelvin, welcome. Please, a little bit about your very interesting and impressive background and your role at A-Star.
thanks, Kevin. Good to be here today. And thanks for inviting me to this podcast. And my background, I'm an engineer by training. I did practice my engineering skills right off the university for a while. And before that, right after that, I joined Economic Development Board of Singapore. And that is when I started looking at the more of the industry policies and to build up specific sectors within Singapore. My last role within that organization was in looking after the international operations. I was based in the San Francisco Bay Area. And after that, it is about 2022. And this is when a lot of climate change and a lot of sustainability sectors are moving towards it. And this is something that really resonated with me. And so I joined A-Star in 2022 to set up this new area of growth and for focus.
Well, that's really interesting. A-Star is a fairly large complex organization, I would say, in my interactions with it, and it covers a number of different areas. For example, human health and potential, and of course, the areas that you're in charge of, but very wide spanning. Maybe you could tell us a little bit about the different types of areas and how you guys think about science and technology and innovation, and how do you actually well, we'll start with that, and then we'll get into the connective tissue of how do you actually make it all work.
That's right. Actually, for A-Star, A-Star is a very unique organization, right? And just for benefit of our listeners who are not familiar with Singapore, right? So A-Star stands for Agency for Science and Technology and Research. And it is a public sector agency, and we are the lead R&D agency within Singapore government, right? And so we have close to about 6,000 scientists and engineers within our ranks, but we reside under the Ministry of Trade and Industry, which means that while we do cutting edge research, we also have a clear line of sight to economic impact. So you can think of us as a bridge between the science and industry. So a good example that we were really proud of is like how we are able to master some of the innovation within a short time that during the COVID, our scientists developed this PCR test kits for the diagnostics. And within weeks, we are able to work with our industry to scale up, not just for domestic use, but for global as well. So you also ask about how A-Star is structured, right? And how
Yeah.
it is hard to organize, frankly, this thousands of scientists. And so the thing is that A-Star has a unique role in Singapore ecosystem. It works at the confluence of policy because we are part of government. We are R&D, so we work with technology, and our mandate is at the Ministry of Trade and Industry for the companies as well. So for the business. So we work at that policy, technology, and business confluence. So most of our R&D is split into broadly into two categories. One is on the Biomedical Research Council, which we call BMRC for short, and also for the physical sciences is a Science and Engineering Research Council, which I belong to, right? And we have about 17 research institutes in aggregate within that council, or research institute, we call it RIs for short. And this houses majority of our workforce. You can view these RIs as centers of excellence, right? And this is their setups is also a reflection of Singapore's priorities and our industry makeup. For example, we have an Institute for Microelectronics, or IME, that supports our semicon industry. So just to be clear, the councils, and specifically for me also, I do not oversee day-to-day operations of our RIs. We have their own management and executive directors for that. So, but what the councils does, and I do in a day job, is to look at the long-term R&D strategies for A-Star and for Singapore, where our RIs then can coalesce and have a focused direction on that. And the last thing that is we also work together at the councils is on the industry side of things. We have a division that is specifically looking at innovation enterprise, and their job is to help us bridge the gap between the R&D and where the industry is going, right?
So, with 17 different, I guess, research groups and divisions, there's probably opportunity to engage in some horizontal thinking, right? I'd be interested in getting your thoughts. I mean, for me, innovation is really kind of a three-ball collision where you kind of have two different types of technologies or two different ways of thinking, but you bring in a third ball, which is the problem to be solved. Maybe So, for example, bringing physicists and biologists together to solve a medical problem, for example. I'm sure there's lots of opportunities that you guys are fostering within these 17 areas. Is it true that's how it works, or are you guys kind of vertically independent?
A star is a highly matrix structure, and I think that is the right way for to do R&D, because R&D cannot reside in silos, right? So the keyword here, Kevin, is agility, right? We need to stay relevant by constantly reinventing ourselves, and I think that is critical, right? So I'll give us a few examples, right? So let's go with sustainability, where my job is, right? When it becomes a national priorities, we can't just tweak at the project level, right? So what we did is, first and foremost, we had to create a focal point and where the crux of the matter is. So we actually set up an entirely new institute called Institute for Sustainability for Chemical, Energy, and Environment, because those are the chemicals and energy, right, are the big areas where the decarbonization need to coalesce and focus, right? And if we now look at that is at one part, but at the same time, as you correctly pointed out, right, we can't have this vertical structure. So we are also looking at how we can operate as an organization. Again, in this climate change, is wide ranging. And it cannot be solved by a single institute alone. And that will be quite undertaking for one institute. So, and also, if you look at it, even take a step back, it cannot be solved by the individual councils, as I mentioned, right? So, if you're looking at chemical industry, now to decarbonize, we need to start looking beyond fossil fuels, and which means that we need to start looking at alternative feedstock, which is a biomass. And now, once you look at biomass and processing of it, technologies like synthetic biology, right, and fermentation, all these become a critical component, and which is what our biomedical side has been pretty strong in doing their biologics or other ways of doing things. So we need to tap on these expertise as well. So it means that we start in like not only so while we create focal points in which we can have a more of a domain expertise, we must be able to pull in the right resources to solve a specific challenge. So that is always a perennial issue, and that is what we are always looking at the agility part.
Right. And as part of the agility, when I've been in Singapore, I've wandered around your Biopolis campus, Fusionopolis, and I'm struck by the fact that there are Fortune 500 companies there, as well as obviously startups and A Star itself. So how do you guys bring these conversations together? How do you actually stimulate entrepreneurialism coming out of the university system, take advantage of these Fortune 500 companies, and really start to kind of build that innovation ecosystem that supports new startups?
One of the things that when I was in EDB, Economic Development Board, and one thing that we need to have most of the international community appreciate is Singapore is a very small country. Like just to give a sense, if you run from east to west, it's just basically one marathon. Right, it's 42 kilometers. So, it's a very short commute, and what that means is that within that landmass, we have a huge, heavy amount of industry. We are the manufacturing hub. So what that means is that we have a high concentration, the companies and businesses, and that melting pot creates opportunities for a lot of businesses. And when A-Star was created, we went one step further because we believe physical proximity is the key. So we built two campuses around and near our National University of Singapore, one of our top universities. And those two campuses that A-Star sits in is across the freeway from National University of Singapore. And so we call BMRC site Biopolis, and Fusionopolis is where SERC or Research Institute sits. And when we do that, we work with our sister agency called Jurong Town Council, who is basically an industrial landlord within Singapore, to create campus so that not only we reside, but also the company R&D centers can reside so that there's a physical closeness. And that is when most of the time magic happens. And it has been great, right? So almost some of the original companies that has been there and they are still around, like PNG, Applied Materials, Abbott, they are there. And at the same time, what's so great about for them is not just a presence of A-Star right next to them, but also the startups that are coming out from the universities, and that is where a lot of magic happens. And we think that is something that we should continue to advocate, and that is something that Singapore can continue to provide that high concentration of talent and ideas.
So, before we pivot into deeper into innovation, two quick questions. You mentioned feedstocks. So, and that Singapore is a manufacturing based society, if you will. But how broadly are you guys thinking about feedstocks? Does your role, when you think about these things, extend into neighboring countries throughout Southeast Asia? And how do you guys pull these things in so that you have the right feedstocks, you have the talent pools, you have the markets, the end markets, which we'll get to for your ideas, right?
That is an ongoing conversation, Kevin. And and Singapore, we given our long-term planning, we created this island called Jurong Island that we reclaimed from several islands that are south of us and created one of the biggest integrated chemical hubs. Right, it is within the top 10 chemical hubs within the world, but at the same time, we do not produce a single drop of oil, right? And we rely on the global supply chain and the trade systems. And now, if you take that analogy, alternative feedstock is nowhere near as established as the current supply chain. So that is something that we need to work on. Right, Singapore, yeah, although we are a manufacturing hub, we are also a trading port, and a lot of our raw materials depend the pace and like depends on how the global infrastructure, be it at the wider scale, even at the regional scale. So that is the conversation we continue to have. So I think the energy transition, right, from fossil fuel to alternative feedstocks, while we believe that is the future, but the speed at which it will grow And the transition period is something that we are always monitoring, and we will work with the rest of the our partners there.
And one last curiosity question: within the Biopolis and Fusionopolis, obviously there are startups that are Singaporean grown. Do you guys have examples of companies from other countries that specifically come to Singapore to work in these, to work with A Star, to work with these companies?
There are a lot, and one of the things that Singapore can offer, right? It's about the market access, right? And the power of this market access or this concentration is that MNCs are like a multinational corporations. They have market access. They have these great distribution networks, and which is great for startups, right? And so that is when they would want to tap on these distribution channels to get their product, to get their technology out, right? And at the same time, for them, these are multinationals. For them, the technology, especially at this day and age, the access to the latest technology to reinvent themselves is the key as well. So there is that creates a symbiotic relationship, which we are seeing tapping on a lot more. In terms of statistics, I don't have them at the moment, but there is a huge number, and Singapore ranks quite highly in the place of business for the startups.
Okay. Well, I think one of the things I really want to get your thoughts on is this idea of intentional innovation. Sitting here as I do in Boston in the startup environment here, it's typically, as you and I have discussed, kind of portfolio driven. It's mass action driven. It's if you throw enough money, you have enough smart people, 90% of the startups will fail, but the 10% that actually thrive and survive will actually transform a market and
Yes.
an industry, right? But you have some specific thoughts on whether that actually works for Singapore and whether that's actually part of the future of real innovation. Maybe you could kind of talk a little bit about your ideas about intentional innovation.
Yeah, Kevin, I think there are pros and cons for both approach. And I do not think that there is a one size fit all or the one right solution for it, right? So intentional innovation is a philosophy that begins with an end in mind, as opposed to the serendipitous one where it is more driven by curiosity and exploration, right? And so intentional innovation tends to work better when there is a certain focal point, certain end goal in mind, and I find that it tend to work in more established industries, right? So, and one of the jobs for the A Star is to ensure that the industries within Singapore continue to grow and grow sustainably, grow well. Right. So from this kind of point of view, then the intentional ones is a key, right? For example, right, we had actively built strong relationship with the key companies in Singapore. So these relationships allow us to get clarity on their problem statements, the need of the individual companies. And if you look at it in other ways, in of the industry in aggregate, right? So once that focal point or the bottleneck is identified, the work for intentionality is a little clearer. So if the problem is specific to an individual company, then we can work on one-to-one basis, right? Then the company will take the driver role because they know what they are trying to solve, and we tend to take a more supporting role where we can. Now, if you look at it from the aggregate, and there can be systematic issue, like for example, in semicon, when you are trying to get into a more and more smaller scale, right? In the Moore's law, or right now we are looking into the advanced packaging, where the chiplet technologies and the key, right, in making more like GPUs. Then it becomes a lot more where government can lean in a little more. So as part of the government, then we tend to build certain platform technologies or certain effort because that the solution or that intervention has a lot more wider like benefits to the industry. So that is how we are looking at it, and it is just it's a byproduct, or I suppose, of how we are set up.
If A Star is developing specific target technologies, is it, do you guys use a licensing model or is it more of an open source if people want to come in and work with you? How does that work with you guys actually generating IP in these key areas?
We have various models, right? And because we work at this junction of industry and technology, the we have to be mindful also of the business commercial, like commercial sensitivities, if you will, and also the
Mm.
speed of it. And there are companies who would like to have retain their competitive advantage. And so for that, we tend to work with one to one, right? And at these partnerships may not even be public, if you will, just because of their sensitivities. And and then there are like consortiums, right? Some of our research institutes run consortiums where the consortiums, even within that, right, you can have a few models, right? One model is of the value chain. So, which means that we will, for example, one of our institutes, Advanced Remanufacturing Technology Center, ARTC, they have these product owners like Rolls-Royce and Siemens, right? And then they will be the one driving the challenge, and then the statements propagate down to their suppliers, and these include startups who will then, hey, I will help you solve it, right? And then we will just
Right,
match
right.
make a match. So there are those there as well, and there are others that we believe it is more of the generated by A Star itself, meaning that we believe that there are certain direction we are going, and there are certain core technologies that if industries alone, they may not want to invest for several reasons, be it technology is not mature enough for them, or it may not be, that's what they're thinking at the moment in terms of prioritization. So there are other things that we will be producing, and for that, and once it is ready, what you talk about licensing, that's when the licensing models and everything will kick in as well.
Now, I guess looping back to something that we discussed earlier, the 17 different divisions. So now that you have intentional innovation, you're identifying what I'll call grand challenges that are very vital to Singapore's future. I would imagine that that actually forces a kind of cohesion and collaboration across these different disciplines. Would I be correct in thinking that?
I suppose so. Yes, I suppose so. And because within research institutes, there are those that are a lot more industry leaning.
Yeah,
Okay,
I
so
would imagine. Yeah,
and so for just now I mentioned IME, the micro electronics. So they are sort of what we will consider a tip of the sphere. They engage with the industry day in, day out, right? And then there will be research institutes like materials. We have right then materials tend to be a little more broad based. They are needed everywhere, but at the same time, they are a little removed from the specific industry problem statements of the industry, because although there's a chemical industry, there's a material industry as a whole. It's not exactly the right place. So for that kind of thing, then we will have to pair up and we will to work together. Right. And so right now, just we are moving towards a lot more of this. One of the things that we have learned over the last couple of years is how US is doing, and like your DARPA programs or
right.
ARPA programs. We thought we love it. I mean, it is about more about mission driven. So meaning that as every RIs has their own capability, it's about, can we then create a mission that is great enough to bring everyone together. Then we work on something. Once something is done, we break off again and everybody go back to what they love to do, and then we start all over again, because I think that agility, that ability to reform or recombine, right, is critical. And I think that is where we want to explore more. Of course, we do understand that it is easier said than done,
Yeah, yeah, yeah,
especially
yeah.
to mobilize a few hundred or a few thousand scientists and engineers. But I think this is something that is worth looking into.
Well, maybe a little bit of compare and contrast because we do debate this here in the US. And typically, with the way that we're constructed, people will say, well, should the government be in the position of making bets? In other words, intentional innovation, right? And sometimes it works, and a lot of times it doesn't. But how does Singapore kind of approach this? And one of the things you and I had discussed earlier was that it demands a lot more in terms of the thinking, designing, and planning and coordination process because you want to avoid the death valley of innovation syndrome, right? Where you build this great technology, you might find one or two initial customers, but you miss the mass market, right? Because you haven't actually thought about the supply chain and critical materials the economics of everything, which we'll get to. And so, how do you guys start putting this all together so that, well, ASTAR obviously is a huge strategic advantage, but how do you actually think about the downstream markets, the supply chains, the partnership ecosystems? How do you guys start putting those things together as part of your thinking for intentional innovation?
We have talked about a little more straightforward cases where we know what the bottleneck is. If the companies are able to articulate it, everyone go for it. I think that I would say is a little more straightforward and easier way to handle because there's a clear and present work to be done. But things get a little murkier when things are a lot newer, less established, as I mentioned. And one of the things for a year or so I've been trying to work out is the techno-economic analysis and the TEA. And that I believe that that tool will be competitive advantage, not just for Singapore, but for all scientists around the world and doing so, right? And it requires a little bit of mindset change here, right? There's this HO adage, right? That saying like just because we can doesn't mean we should, right? So the TEA techno-economic analysis at least give us the info. Should we do it? And so that then we just start to think about it because a lot of times um, the scalability it's a quite a big thing and when it's not trivial because scalability has two parts to it, actually more than two, but I'll make it simple. One is technology scalability, right? There are times when for specifically for sustainability people tend to focus on a unit ops, let's say a catalyst or certain solvent. They are able to solve it, but the thing is, but to create at the supply chain there are so many steps, and then if you combine it, so you need to keep solving everything at the system level before you can start feeling the impact. Individual pathways, although while it is you can write great publications and like a great yield on paper, but it does not have the real world impact to it. So that is a system scaling part. Now, business scaling part is even if you do all that, can you make money out of it? And and that is actually is a bit unfair for the scientists because that is not the I
It's not
suppose the
typical training, right? Yeah.
it's it's not in their nature, right? They are and they are great, but that is where business side needs to come in and to talk about, hey, yes, like your solution is great, but in order to do that, now if you have to build another $1 billion manufacturing plant,
Right, right.
the investability may not be sensible for companies because for them it is another investment again. That is not just another investment, but it's an unproven investment. So that is where, at least for TEA, as you talk through all these steps by step, at least it is about education. At least it is about that for them to be able mindful of the fact that to make a real world impact, they need to think a little more differently. They need to think in the systems.
Well, I think there's a lot of different benefits to TEA, and you're right. I mean, certainly when I was growing up as a scientist and doing R&D, these things don't really come to the fore until you generate some IP, and then somebody asks you the question, well, what is it worth? And how much will you charge, for this? And then you realize you don't have any clue there. But another, you mentioned interestingly, I think it jogged my memory that I once worked with a chief scientific officer who said, before we launch a new product, we have to figure out how many hands are out there waiting for something that we have to give them in order to get access to their markets. Do we really understand the supply chain, the distribution, the motivations, and the incentives that are in
That's
play?
right. That's
And he
right.
said, if we can't model that, then we don't know how to price our offerings, right? And we don't know what our cost to deliver is going to be. So these are things that I think I'm on board with what you're saying. That if we could train the engineers and the scientists to kind of master different aspects at different parts of the R&D process, right, from ideation to kind of all the way down to implementation, that would be great. But how do you propose to kind of start building that? Because that seems to me like to be kind of curriculum. And it's probably because you bring it from your economic development board experience, right? You bring that economic thinking to A Star. But as you mentioned, you've been there a couple of years and you're running a few of the verticals there. So how are you kind of starting to inculcate that or to kind of disseminate that thinking to your colleagues?
I've been thinking that myself, right? So in a star, we have a dedicated team of TEA specialists, right? And that is housed under one of our research institutes that has been doing manufacturing, and they came out of that, right? And I can't take credit for that. It was they have been doing this as part of their manufacturing scale up work and whatnot, right? Except that where we have been a lot more leaning on them is for the sustainability part of things. It's a little straightforward because, especially for this decarbonization, right, that both technical risk and the business risk is real. Like there are so many companies they believe is a morally is a right thing to do, but as they do it, it becomes more challenging. They need to balance their day-to-day operations and the profitability with the new investments that will come along. And at the same time, the apart from that too, there's also the external risk. Policies like carbon tax alone can change sway the whether the business can be profitable or not, right? So back to A Star. So this TA team has become a lot more instrumental, at least from what I've been trying to do. So for them, they serve a few purposes, like that. They have been working with me for a while. At its core, the team acts as our center of excellence, be it for the methodologies, be it common database for any model we apply, so that anything that we do is at least consistent across a project. Otherwise, you may be comparing apples and oranges for
Right.
for the
You could
projects,
have a
and
million
it can be
models running
very
around,
difficult.
right? Yeah.
That's right. So that is the first, at least core. And the second is that they also start to behave as change makers as we get them to interact more with different parts of our research institutes and different scientists, they impart that mindset just now we talked about. And so that is sort of it is always good to have that peer-to-peer exchange and to get that knowledge. So more recently we started doing these workshops within A Star where they start talking about like how they should think about it and whatnot, right? And what they also do as part of this is they started creating these simple tools because you also don't want to overdo it, and in a sense where to the point where it stifles and you are just like stuck in this analysis paralysis. So it is
Right.
more of a simple tool. Hey, am I solving the problem that is the biggest bottleneck? Because when you are now looking at, let's say, a yield, if you can double the yield from, let's say, 16% to 32%, right? Now, at the system level, what does that translate to? Right. You even if you double it, but then if that is not the bottleneck, you
Right. Right.
you may not be having the impact that you think you are having. But in chemicals industry, right, especially these the more of the platform chemicals, single percentage yield increase because just by the pure volume it is in billions and millions. So
Right.
now you have to have a certain perspective to it. So you need to put that into a context of whatever that you do. So that's the second part. It's about culture change. Whether are you thinking it right? Then the last part that we have been also able to get a lot more transition. Just now I talked about policies and then the externalities, right? So this team has also found a niche within our government ecosystem because now we are Singapore is one of the few countries in Asia that has implemented carbon tax for a while now. We have stated some of the trajectories so that we give our companies certain visibility on how to do their business planning. So, but as we do that, the question is how our pace of change is it scientifically informed by the TEA? and how
Right.
the technology can come in. So this team has become a quite indispensable or quite a critical part of that process, and especially on looking at our pathways to net zero, because directionally I think every country recognizes that, and there we are going to that. The where then the nuances lie is the speed of change, the pace of change, and even how you're going to change it, right? So these are the where the information comes in, and that's what the TEA team. That's also basically that's a gist of how at least A star version, one way of doing our TEA.
I think that's great. And, the way we think about TA is through risk scenarios, right? So,
Right.
like, and we run all the way from very pessimistic, where we're 100% wrong, to our wildest dreams and everywhere in between. And we find that that thinking process helps us identify opportunities, niches, as well as risks, right? And being able to kind of codify that and put it out there for debate and mitigation, I think, is actually a very powerful tool. So
That's
completely
right.
aligned there. Before I let you go, a couple questions on sustainability. We're very interested here at FSX on things like thermal management, carbon management, CCS, energy and grid stability. You mentioned that you guys don't produce a single drop of oil. So sustainability, energy, data centers, AI, manufacturing. What are your thoughts?
That is that is a big question, Kevin.
Yeah, yeah.
I
Now
don't
we have
even know
another
where to
2 hours here,
start.
but no, I'm just joking. But like, how do you begin to kind of just break it down in terms of, okay,
Okay,
what is sustainability and how do we actually handle this?
I think all right, let's get the biggest news out of the way. AI, right? AI is it's gonna change. It's gonna change how we do things. And a lot of people, like if you read it, we're talking about how AI is gonna change businesses and how we do things. And I think for A Star, we have to start thinking about how AI impacts R&D,
Yes.
because that's our business, right? And there are a few parts, in my opinion, that first of all, AI, the pace of change will be a little quicker, right? And there's this thing I read it off some book, right? Like the pace of change has never been fast, but it will never be this slow ever again.
Right, 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 right. And there are
you
numerous
know,
corollaries to that. Yes.
yeah, it's I thought I like it, it brought a chuckle because it's true. And the thing is, how do we gear up? How do we now, as an organization, can we keep up with the pace of change? Already, R&D, we talk about how the R&D timelines and the business timelines are different, and there's already a gap. That gap needs to, as we are now trying to catch up with that gap, this the speed of business is going to go a lot faster. So AI, how do we do that? So a few thoughts, right? So, and one is about if you look at AI for materials, using AI for material discovery. I think this is one of the few things that Google and everyone has been working on. But now, if you want to extrapolate it, right? So for one of the projects that I'm quite excited, and we are now trying to bring it to the deployment, is low carbon technology translation testbed, or LCT3 for short. And so that is a facility, and it is trying to solve a few things. Because if you now look at sustainability, we need both speed and scale, because without scale, there's no impact. It's a global problem. And without speed, we know that our 2.5 and 1.5 degrees, we are catching up. The glaciers are melting and everything. So we need to do both at the same time. And for countries for CCUS and what you talk about, right? And you can do it because if you have enough land and enough manpower, you can go around building a lot of these, testing out. Let's try it. But Singapore, we have limited options on that. We have very limited land, and more so for the talent. We are a population of about 6 million people. We need to use it wisely. So this facility, LCDQ, right, it is about using modular systems so that we can keep reusing the equipment so that we can fail fast, right? And
Right,
then we
right,
move on.
right.
And now the added component of that is AI again, digital part. Because the way normally the chemical industry tend to do is let's build this scale. Let's say go with 100 some gram scale at the lab. Then let's go to 100 kilogram. Then let's go to a ton. Then now can we go to millions of tons, right? So then they keep scaling it up. But now the question is, can AI predict this faster without having to keep building heavy infrastructure? And can give us do that. So back to that, right? So that is how we are looking at it and see if we want to do that a lot more of that. And I think that it is about how we use it, how we master these new technologies that are coming up.
I love this idea of modular innovation building blocks for infrastructure and build it once, use many times. If you can define it and you can see the adjacencies and the relationships and applications, whether it's bioeconomy or manufacture next generation chips. So
That's right.
that's quite fascinating. Let me end with one question. So, and this is more for our audience at FSX. If I'm an entrepreneur or investor or Fortune 500 company and I wanted to get plugged into that Singaporean innovation ecosystem, what would I do? Who would I approach to get started?
I'll put it in two broad buckets, right? If you are overseas based right now, you're outside Singapore. Our sister agency, my previous organization, EDB has several offices. They have over 20 offices across 14 countries. So EDB is the right partner, like you, because it's in your time zone. You can just call them up and check it out. But if you're in Singapore, right, A Star, we are located in One North. You can contact any of the research institutes. We have a lot of them. They have their own like business engagement team that they can help you, right? If not, my name is there. You can always hit me on LinkedIn. I'll be happy to get you in the right contact and get you help started. And I go back to the point where Singapore is we are small enough. Well, we are nimble, and we need to be a little more. There's no wrong door, right? So you can always get in touch with us.
It's a great way to end. So, Director Zin, it's been a delight to speak with you here. Thank you very much. And for those of you out there, if you'd like to continue the conversation with us or Kelvin and learn more about A-Star, please feel free to reach out to Kelvin or any of his colleagues or contact us at FSX via our website, FutureScaleX.com. Thank you.
Thank you, Kevin.
Oh, thank you. This is great.